Welcome viewers, in this video we will see the solved problem based on the tuned circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic tuned circuit solved problem 1. We know that tuned circuit is done by the connecting capacitor both in primary and secondary coil. If only connected in secondary coil is called single tune. Connected in both primary and secondary means double tune. That is, the reactive inductance is equal to reactive capacitance. So both got cancelled, only the circuit behave like a resistance. That is called a tuned circuit. Now we'll see the statement of the problem. In a series fed doubly tuned transformer circuit, both the primary and secondary are tuned to the same resonant angular frequency of 10 to the power 5 radian per second. The maximum output voltage across the capacitor is 24 voltage and is obtained by varying the K. K is nothing but coupling coefficient. If the inductance and the resistance of the primary circuit are 4 microhenry and 0.1 ohm respectively, and of the secondary circuits are 50 microhenry and 1 ohm respectively. Calculate the supply frequency. We need to calculate the supply frequency. Now we'll see what are the data available one by one. So the resonant frequency is given for both primary as well as secondary side. Resonant frequency omega r equal to 1 divided by square root of L1 C1 primary circuit. That is equal to 1 divided by square root of L2 C2. So that is equal to 10 to the power 5 radian per second. So this data is available. Both are tuned at the same frequency. So we can use this expression to find the variables. And maximum value of E0 is 24 voltage. And L1 is given 4 microhenry. That is 4 into 10 to the power minus 6 Henry. L2 is 50 microhenry. 50 into 10 to the power minus 6 Henry. RG is 0. The source resistance is not given. So assume to be 0. We need to find the source voltage EG. R1 is given as 0.1 ohm. R2 is given as 1 ohm. Right. First, from the given data, the resonant frequency is given. So I will use this formula. 1 divided by square root of L2 C2 equal to 10 to the power 5. Now square on both the side, so that 1 divided by L2 C2 equal to 10 to the power 5 the square. Right. Now bring the C2 in the numerator, this side. 10 to the power of the whole square in the denominator, that side. So 1 divided by L2, 10 to the power 10. 10 to the power 5 square is 10 to the power 10 equal to C2. So that is C2 equal to 1 divided by L2. L2 value is given as 50 microhenry. 50 into 10 to the power minus 6 into 10 to the power minus 10. L2 value already available. So from that C2 equal to 2 into 10 to the power minus 6 farad. Otherwise 2 microfarad. Now the C2 value is calculated. Our aim is to find the source supply voltage EG. Now we'll see how to find the supply voltage. So the maximum E0, maximum value of output voltage E0 equal to EG divided by 2 omega r C2 square root of R2 into R2 of Rg plus R1. Because the maximum E0 is given in the problem. And other values also available. C2 also now we calculated, so that we can easily calculate the output voltage EG. Now cross multiply this, all the terms multiply here, so that EG equal to E0 into 2 into omega r into C2 of square root of R2 of Rg plus R1. All these terms are multiplied with the E0. Right. Now these all the values are available. Right. C2 just now we calculated. So E0 is given as 24 into 2 into the resonant frequency is 10 to the power 5. C2 what we calculated 2 into 10 to the power minus 6 into square root of R2 is 1. Rg is not given, assumed as 0. R1 is 0.1. So by simplifying this we got 3.036 voltage. Now the in source supply voltage is calculated. So in this problem we discussed the solved problem based on the tuned circuit. We calculated the supply voltage. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.